Hello and welcome to this, the fifth class of the course of GIS in Water Resources. My name is Saul Montoya. Please welcome to this class where we are going to do this from the course material, session 5 on the manual. We are going to work with the NDVI, and then we are going to work as well with to do a simple approach to get a water table. Okay, so let's start. Okay, the objective of this exercise is to determine the normalized index, the normalized vegetation index. Okay, and for that we are going, this is an old procedure, you might have done it. Okay, what is new is that this, based on the different web servers that were available, maybe this procedure is new for you. Okay, because even for me, I have done that just with this web server just 3 times. Okay, so here we are in search airdata.nasa.gov, and here we are here, and I am already logged in, so you need to be logged in. Okay, and then here we are going to use sorry okay, so here we are going to insert a point. Okay, here we are going to insert a point, and then when you insert a point, you have to insert first the latitude, that will be 7.363, and the longitude will be 78.010. Okay, so this will be in the chat as well. Okay, great. So here this is a point in our area of study. Okay, and then we are going to look for Landsat 8. Okay, Landsat 8, great. Landsat 8, and then from Landsat 8 we have lots. Enter. We don't have that much, so let's say okay, this is tricky. You have to look for Landsat space 8. Okay, let's look for that. Okay, so here we have more, however we have lots. Okay, so here we have to look for we have to be operational. Landsat 8 operational, even that. Sorry, there is a lot of data here. But if you type okay, what happens if we use just Landsat? Crappy. Let's see what happens if we use Landsat 8. Okay, let's say Landsat 8. Nothing. So crappy. Okay, sorry. Yeah, this is an issue of this server. Okay, no, it's not mine. Landsat 8 only. Okay, operational land imager. Well, it's actually this one, Landsat 8 operational land imager and thermal infrared sensor collection 1 VO1. Okay, if you could find it, please type yes 1. If you could find it, please type yes 1. Okay, so this is the This is the collection Landsat 8 operational land imager only, and thermal infrared sensor tiers collection V1. Okay, great. And then on the timeline, here on the timeline, we are going to work with of year 2013, the 1st of July of 2013, and as well here of 2013, July, the last day of July. Okay, and that resumes just to one digital image. Okay, okay, I will do it again. Don't worry. Okay, I will do it again. Here I am in my Landsat image. Okay, what I have to do is that I have to add a point, and the point will be minus 7.363 comma minus 78.010. Okay, this will be my point. Okay, if you do click here, actually it will represent your point here, and then you just type Landsat 8. This could be better because actually, and then you have to look for the Sentinel, Aster, Sentinel. Okay, Landsat 8, enter, by the way, Landsat 8, enter, and this will give you the most related Landsat, the most related image to the term that you have inserted. However, this is not the most related, because what actually we are looking for is like on place. Okay, so for me it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, on place 11. Okay, this is the. Okay, great. So, and there is a lot of data from the Landsat 8 for that place. However, we are restricted here to the 1st of 2020 July, the 1st of July to the 31 of July of 2013. Okay, if you are here, please type yes 1. Yes 1. If you are here, please type yes 1. If not, I can give you this whole address. Actually makes the links directly to you. Yeah, because this is kind of URL. Yeah, this is just in extreme case. However, okay, yes 1. Great. Manal, could you do it? Okay, great. So let's download this. We can do download this, or we can do download all. Okay, download all, and then we can go to direct download or download data. Yeah, and this will give you that is the, but this is for Air Explorer. Okay, and this is another one. This is this is a server from the USGS. This is not a server from the NASA. So if I do click here, I need to log in here. Okay, you need another account here. So this I will sign with my account. Yes. Okay, you have to sign with your account, but okay, in this class, or you can create your account, you can create your own account. Okay, however, okay, I don't remember this one. So I forgot my password. I am retrieving because this is another server. Okay, so if you can create your account, however here I have to. Okay, I will try again with my username. The problem is that I don't get this. Okay, okay, where we are going, actually we are going to follow the manual here. I don't know if you have an account. So I don't know if you have an account on this server. Okay, you can do it this. Okay, those are not the same. Okay, yes, those both are not the same. Okay, so you need an account from the USGS in order to have an you need an account of the USGS in order to download it. Okay, are not the same. Those are not the same. Okay, so if you even try to download here, you have to create an account here. Okay, since we are not going to do this, what we are going to follow the procedure. Why not? Because the image weighs around 900 megabytes. Okay, so once you have your account, you are going to download this, the last one, that is the GeoTIFF level. Okay, and this is the natural look. This is in case, I mean, we have done a tutorial on machine learning over to extract water bodies, and this will be done with this one. Okay, however, we are going to work with this one. Okay, for you, on the course material, on session 5, on practice, on data, on raster, we have the what we have is the Landsat image that we are supposed to download. Okay, where is this? This is in the course material, and then you are going to extract here. Okay, then you are going to extract those data here. Okay, if you are here with me, please type yes 1. If you are here with me, please type yes 1. Okay, and if you are, no, yes 2. If you are here with me, please type yes 2. Okay, what you have here are the different bands. Okay, so Landsat 8 has 11 bands, while Landsat 7 has only 8 bands. Okay, and while Landsat 7 starts from blue, green, red, and near, in Landsat 8 they start with band with coastal, and however the green one was, sorry to show you, I'm going to close this. Okay, while the green one starts with is band 2, the green, no, the blue one is band 2, the green is band 3, the red is band 4, and band 5 is near. Okay, while in Landsat 7 band 4 was near infrared. Okay, okay, great. And then if you have seen this, there is a name here, so I say Landsat 8. So this is L comes from Landsat, X comes from Opera, C means the sensor, so in this case is Landsat 8. Yes, okay, this is the pattern row, so this is a quadrangle of the Landsat. Okay, this is the date, so this is for year 2013, July, 16th of July. Yes, so this is the when it was, this is when it was taken, and this is when it was processed. Okay, I guess. This is the band. This is somehow the convention to get information about the image. Okay, great. So we are working to, okay, so let's understand. This is band blue, green, red, near infrared, blue, green, red, near infrared. So because this is what I say, blue, green, red, and near infrared. So these are the ones that we are going to use, where the red and the near infrared are the ones that we are going to use in order to get the DVH vegetation index. Okay, great. So let's say so let's say, let's open, okay, according to the manual, let's open our QGIS. Let's open our QGIS. Okay, so we are going to work. Let's remember that according to this information, the band number 8 has a resolution, this band has a resolution of 15 meters. Okay, so that's why it weighs more, it weighs 4 times more than the other ones. Okay, so let's see this. Okay, and that's it. So let's go and add the layer. So here in home, let's go to the course material, let's go to session 5, let's go to practice, let's go to data, let's go to raster file, and here what we are going to use is number 4 and number 5. So there are two, number 4 and number 5. I can make it in order as well. Number 4, number 5, number 4 and number 5, and this is for red and this is for near infrared. Okay, great. Okay, that's everything that we need to know here. Actually, those both are already in UTM, and then these are, if you see, those are in UTM, but since the data provider is in the northern hemisphere, actually we are in the UTM WGS 84, however with the north zone, and this is why we have some negative value of our y coordinates. Okay, yes, so but there is no problem, we can reproject this into the south. Okay, if we are here, please type yes 3. If we are here, please type yes 3. Any questions? Let me know. Okay, great. So let's go here to raster and to raster calculator. Okay, so the NDVI is this formula: near minus red, okay, divided in near plus red. Okay, that's it, that's the formula, yeah, of the NDVI, the vegetation index. While the NDVI is closer to 1, means that it's more vegetated, while this is closer to 0, this means that it's less vegetated, and whether is negative means that there is a water body or other issue. Okay, so here we start our parentheses. Okay, so this is 5 minus 4, meaning near infrared minus red, close parenthesis, divided, open parenthesis again, in near infrared plus, or red plus near infrared. The order of the dividend is, this is a plus. Okay, yes, so this is the equation, and this says that the expression is valid. Okay, so and then we can store this on our exercise folder. We create a session 5. Okay, and here inside session 5 we create a RST folder, and then here, and this will be called NDVI, and it will be a GeoTIFF, and actually you can select everything here. However, I don't actually, okay, I know this tool from long time ago, sometimes it doesn't work to, I mean, it works better if you store as a geotiff. Sometimes it says that it can store that as another file, but it's not true. It's not true. Okay, sometimes it doesn't work that well. Okay, if you are here with me, please type yes. If you are here with me, please type yes 4. Okay, great. So it's calculating, so actually it's quite heavy, the calculation. And then we got this NDVI image. Okay, so we have -1, but those are the ones of these empty, or these empty black spaces. Don't worry, so because we are going to omit those. Okay, so what we are going to do, since we are working with, I mean, this has inherit the system of reference of the previous one. So this is actually WGS 80. Okay, this is actually WGS 84 zone 17, but this is north. We have to reproject it to south. Okay, so let's go here, and then here let's say var reproject, and then this from NDVI, let's project to 32717. Okay, so this will be WGS 84 UTM zone 17 south. Okay, zone 17 south. Okay, well, and then we are going to store this as, we are going to save this as save to file. This will be on session 5 raster, and this will be NDVI 17 south, because it's on 17 south, it's not on 17 north. Okay, so yes, run. So what do I get here is what do I get here is the NDVI 17 south underscore 17 south, but this is already in WGS 84 on the southern hemisphere. Okay, great. Okay, great. So actually, well, there is an issue here, is set project CRS from layer. Okay, well, actually we are only interested in this one, so we are not interested in all the other ones. Okay, so we are going to remove all the other ones. But if you see here, the project system of reference is still on 17 north. So what we are going to do is that we are going to change this as well, but first remove this. Okay, and then here let's see, let's use this set layer CRS and set project CRS from layer. What it will mean is that it will use this CRS, this system of reference, for the to set the project CRS, that is this one. Okay, so if we use this set project CRS, and it has changed this to 32717 because this is the system of reference of this. If you are here with me, please type yes 5. If you are here with me, please type yes 5. Okay, great. So let's continue. Okay, so we have already reprojected, and then we can get from the session 5, from the course material, we can get on the shape file the upslope area, because the upslope area is just a small part of the whole landscape. Okay, so what can we do here is that we can clip the raster. Okay, so we can clip the raster because we are not interested in the values of the NDVI outside the basin. Okay, we are only interested in the values inside the basin. Okay, so and here in processing will be cut raster cut okay, let's do it again raster. Okay, and this is GIS. No, it's clip raster by mask layer. Okay, clip raster by mask layer. Okay, so since we have only two layers here, so the input layer will be our NDVI 17 South, that is on this is the code for 17 South, and the upslope area is in the same code. You have to, I mean, I don't know if QGIS could make the reprojection here, but actually I strongly recommend that you check always that you are working the same system of reference. Okay, great. So what else we are going to do? Nothing else, and then we are going to store this. We are going to store this, the clipped mask we are going to store as NDVI 17 South cut basin. That means that is already cut to the extension of the basin. Okay, this is cut basin, and this is cut to the extension of the basin. And then we run. Okay, and then what we will have is this. Okay, so it's a better representation where we have some values And then here we have a cloud, so actually we cannot deal with that. Okay, so we don't know what we can do, but this is actually something that we have to be, I mean, it will represent a negative value, but in fact it is only a shadow. Okay, so here we have the basin. And then what we are going to do is that we are going to create some contours. Okay, then we are going to create some contours here. Okay, the contours will be, I mean, the maximum value is 0.56, and these are the valleys. Okay, the valleys have the value of 0.56, and all the vegetated parts. Okay, and I can do something here, yeah, because it, I mean, it will create some values, yeah, but it, those values, I mean, it will have, the interval will be 0.05, so actually we will have 12 types of contours, okay, something like that. And the process is not so fast, so let's see if I can do a reclass uh, raster tool reclassify values. A ver, let's see if we can do this. Okay, I will try that. They say from minus 1 to 0.4 will have a value of 0. Okay, let's say what I have done is, I say from minus 1 to 0.4 it will have a value of 0. Let's see, and it will be stored as temporary file. And the method will be range. Let me see. Operator for single value. Well, the method is range. Okay, so let's see. Operator for table. Okay, sorry. Okay, no, I'm not going to do that. Okay, but let's see that the process could be done faster if we do a reclassify. In our case, what we are going to do is a contour, and GIS raster extraction contour, and then we are going to contour from the sub-basin, and then we are going to do a band 1 gray. The interval will be 0.05, and then this is the attribute table will be NDVI, so this is what will be stored on the attribute table. Okay, that's it. So this, and this. So this, and this. So let's run. Yeah, you will see that the process is really slow. Why the process is really slow? Because yes, there is a question of see, it's not clear how we can see the value of the different NDVIs. Okay, let's see. I will show you from the contours what it will mean an NDVI of 0.45 and where this is located. I will show you once this process is done. Okay, but if you are till me, please type J6. Okay, in the areas that are more vegetated, the NDVI will be higher, while in the areas that are arid, the NDVI will be lower. And when there is a shadow, or when there is a shadow, or when there is a water body, or even an urban area, it will be minus. It will have a negative value. Okay. So let's keep it up. Okay, let's keep it up. And then if you will see, if you go to the folder material on session session 5, oops, I'm sorry, it's doing a temporary file. Okay, it's doing a temporary file, so that's why I cannot log exactly where I was intending to. Okay, still working. Okay, still working. Okay, great. So here we have the different contours. Actually, it's quite a heavy shapefile. So we are going to do on properties, right click on properties, and I hope that for you it has worked the same. And let's go to do a graduated over the NDVI, and then the color will be greens. Okay, so we do a classify. Okay, and then I will show you what does it mean this NDVI. Okay, once again, okay, what I did is right click properties. Okay, here I went to graduated, I selected NDVI here, and then change it to greens, then classify, and then okay. But what does it mean this index? Okay, you will see this index if you add a Google satellite at the bottom. No, okay, and then the contours at the top, and just the contours and the Google satellite. Okay, so if you are in an arid zone, actually this is close to zero. But if you are in a valley like this, actually you will have higher values of vegetation there because these areas are vegetated. Okay, that's why, because those areas are vegetated, that is what you are going to have the higher values of NDVI. Okay, while in those arid areas you will have zero. If you are here with me, okay, still processing, but once you are here with me, please type yes 6. But I hope that this show you which is the impact of the NDVI, that it points the areas that are vegetated. Okay, I will do another explanation. In Peru we have two seasons, dry season and wet season. Okay, July isn't our dry season, and in our dry season we have no, how say, snowy winters. So actually it means that there is no rain, and there is no snow and nothing. There is just simply there is no rain. And then if we have some vegetated areas, those might be wetlands. Okay, so those might be, because groundwater will be the only source of water for the vegetation on the dry season. Okay, that's why, and this will be the uh, reason why we can, by doing an interpolation over the wetlands and over certain parts, we can have a sense of what will be the groundwater level. Okay, so, and they say, can we style this? Yes, sure, we can style the raster as well. Properties, symbology, single band pseudo color, greens, classify. Okay, but in your case from -0.1, because otherwise the colors won't be the same, something like that. Okay, great. You can classify this as well from the raster. Okay, if you are here with me, if you got the contours, please type yes 6. If you got the contours, please type yes 6. If you got the contours, please type yes 6. Okay, great. So here I'm going. Okay, so we are interested in the contours, but we are interested in the contours where the NDVI is higher and equal to N 0.45. Okay, that means that those are areas that are or really high or a certain value of interest in vegetation. Okay, so we are going to do a filter here, and then we are going to say NDVI minus equal to sample 0.45. Okay, once again, right click, filter, NDVI, no, sorry, here filter, NDVI higher equal to 0.45. Okay, we test, and there is 5,000, more than 5,000 rows that fit those. Okay, and then we type okay. Okay, great. Okay, I will turn off because the color green actually is being deterred, or is being hidden by the green of the satellite image, so actually you cannot see. But this is an area of high intense vegetation on the dry season. Okay, great. So this is why 0.5, because this comes from, let's see. Okay, there is a great question. Let's see that we have here, okay, and this is a digital satellite image that is not in the wet season, okay, but we see that could be some areas. Okay, 0 means arid zone, and 1 means high complete dense vegetation, and 0.45 means it's close to an intermediate vegetation, a subjective intermediate vegetation. However, if we put 0.5, the values are going to be really scarce, because actually on 0.45 we even don't have that much values. Okay, and if we put 0.3, we can be considering areas that are not of intense vegetation. So this is really subjective. 0.5 work for us, and what it will mean, what it will be, it's of great success, or like of is going to the field and to trying to see which is the end. I mean, if you go and see, okay, to the field and say, okay, this is my area, and they say, okay, this area for me is this value, so you can update your limit. Okay, or say you go to a wetland and say, okay, this is a wetland, and for me, on the Landsat image, this is an NDVI of 0.37, for example. Okay, so I filter that by values higher than 0.37. Okay, so we are going to store this, export, say feature as, I mean the filter values, and those will be on the folder material, section 5. Let's create a raster, no, a shapefile. Burned areas, there is a question, what will you do with burned areas? Actually, burned areas are in, there is a MODIS land cover. There is a burn or fires. There is a there are for burned areas, there are other images that can give you the fire, I mean the burned areas, and then, well, I did something with modis. mm, there are certain modis that was just to represent the burned area, but there are others, so it's just a matter that you find the, but it's, and I think that those are in the modis ones, so you can review this in order to see which are the ones that you. Okay, so this will be called NDVI, 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 17 South, cut basing underscore contour underscore query. Why? Because those are all the steps of this shapefile. NDVI is in the 17 South, cut basing, contour query. Okay? And that's it. We don't need to do nothing else. And then we have this, but just we only have the contours that are higher than 0.45. Okay? If you are here with me, please type yes 7. If you are here with me, please type yes 7. Okay, great. So what we are going to do, okay, in order to interpolate, we cannot interpolate with contours. Actually, you can do it, but it is not advisable to interpolate with contours. Why? Because contours have a lot of vertex, okay? So it's better to interpolate with points, okay? But even that, we have contours here, and then we have to simplify. Why we have to simplify? Because if you have contours like this means that you have a lot of vertex, and on the interpolation you will have kind of a dense, cloud of points that will shape your interpolation in ways that you are not intended to. Okay, so we have to, one solution of this is to simplify the contours, so in this way we are going to have less amount of points or more distributed amount of points. So how do we simplify? There is a tool that is called here simplified. According to the manual, this is simplify on vector geometry, simplify, and then we are going to simplify our query, okay, and the tolerance will be 10. Okay, you will see what does it mean. So, and I think that this means that if you have 10 points over, if you have 8 points over 10 meters, this will be represented as just 1 point, okay? And this will be stored save to file to shapefile, and this will be called query, and then simplify. Okay, great. So this will be simple, okay, and then we run it. Okay, here we run it. Okay, okay, and then we have the simplified. Okay, this is the options, and then we will see. Okay, I will give another value here like red, something like that. Okay, and then we'll see that we have less amount of vertices for the simplified version. Okay, great, great. Okay, if you are here with me, type yes 8. Okay, yeah, this is not too smooth, okay, because smoothing is like trying to create more rounded vertex. Okay, this is just to simplify, to decrease the amount of vertex. Okay, then what we are going to create is that we are going to extract the vertex. Okay, so where we are going to see, we're going to extract the vertex, extract vertex. Okay, extract from vector geometry, we are going to use extract vertices. Okay, from vector geometry we are going to use extract vertices, and then we are going to get the simplification, and then we are going to store this to file to nodes. Okay, why? Because we want to store just the nodes. Okay, with that, because this is a line and the resulting shapefile will be a point. Okay, so let's run, and then you will extract, and then you will have a point on every node. Okay, if you are here, please type yes 9. If you are here, please type yes 9. Okay. Why do not convert the raster to points? Why? Because this is the raster, and the raster is many points. Okay, if we do a filter, we will have, the problem is that you will have, and then you will see on the interpolation, when you do an interpolation, an area interpolation, then you have a dense, I mean, you don't have, for example, here we are not going to have data, and here we are going to have data. If you have a dense cloud of data here, of points here, actually this will have an influence on interpolation, and you won't have a smooth surface, okay, when we interpolate. Okay, that's the reason. Okay, so here we have the vertex, and finally here on raster we have the UTM, that is the elevation, so we are going to place it below here. We are going to place it below here because we are going to extract the elevation on this of these points that has high vegetation, because those most probably are wetlands, and how we are going to do that? We are going to do that by doing click here. Now we're doing on the point sampling tool, the complement of point sampling tool, we are going to work with NDVI nodes because this only works with 2 points, and this is the only point layer that we have. Then we are going to get the UTM, the Cuenca Digital Elevation Model, and the field will be called elevation. Okay, so this will be the field name. So, and then we are going to store this as nodes 3D. We are going to store this on the course folder material and the exercise folder as a shapefile, and this will be nodes and 3D. Why? Because those have a higher elevation. Okay, so these on fields, this is called elevation, and here it has been projected to this digital elevation model. Okay, and that's it. We run it and it's 34,000. Okay, 34,000 points that if you open the attribute table. Okay, first, if you are here with me, please type yes one. Yes one if you are here. Yes one if you are here. You'll have to store it as nodes 3D, and the field will be elevation. Okay, yes one if you are here. Okay, I will repeat the step. Okay, great. Remove layer. Great. Okay, here I have the nodes. Okay, here I have the nodes. Then I have here the point sampling tool, that is the complement. Okay, the complement, this is the, it will point as the nodes, is the only point shapefile. Okay, and here I'm going to, okay, from the course material on session 5, I have a, besides the Landsat image, I have a digital elevation model. I have to open this. Okay, this is the digital elevation model. Okay, and then I will place it below the nodes. Okay, and then here from point sampling tool, this one that we have worked with this complement, with this plugin before, please tell me. Okay, and otherwise, if you don't have it, you just have to go to plugins, manage and install plugins, and then you will have point sampling tool, and then you can install it. Okay, here on point sampling tool, you just work with the nodes, then you are going to project to this digital elevation model, then you are going to call the attribute of elevation will be elevation instead of this, and then you are going to store this on the exercise folder, session 5 shapefile, as a shapefile. Okay, with this name. Okay, if you are here, please type yes 1. If you are here, please type yes 1. Okay, okay, then we have the nodes. No, then we have, by doing this, we have this that has already the elevation as elevation, sorry, yeah, I will do it again. Yes, because no, this is a course material, sorry, and on the folder material, on the exercise material, session 5 shapefile, and then here we have nodes 3D, and those ones has elevation as the attribute of elevation. Okay, great. So here we have the elevation as the attribute of elevation, because we are going to need this in order to interpolate the, we need elevation because we are going to interpolate these elevations with the elevations on the of a certain part of the string network, because from certain part of the string network the rivers are gaining rivers, so actually base flow are taking water out from base flow, or base flow is draining to the rivers. So by interpolating the rivers and this, we can do a small and very approximate distribution of the water table. Okay, great. If you are here with me, please type yes 2. and we are going to make a break here of 10 minutes in order to go to the restroom, pick something to eat or whatever you want to do, and then we see us in 10 minutes. So this will be 7:33. Okay, so notepad, and then say here pause 10 minutes. We are back at 7:34 p.m. Okay, let's make the pause. If you have any question, you can drop it on the chat. Hello, we are back. Okay, we are going to continue our course. So what is missing here is to save our project. Save our project as on session 5. Let's open here a QGIS folder. And inside here, this will be called part 1. Part 1. And then we create a new project. Okay, all the temporary layers will be lost, don't worry, because we have already stored what is interesting for us. Okay, so let's work with the session 5, manual. Let's do the water table. Okay, so let's start. We are going to work with on the course material on data. We are going something similar that we have done to the wetlands is to extract the elevation of the points related to the wetlands. We have also to extract the elevation of the point related to the river. So here on the course material on session 5 we are going to use, this is the river basin, okay? And then here I'm going to use I'm going to extract vertices, the same extract vertices, okay? So this is in vector geometry. There are extract vertices from the river basin, and this will be saved to file. Which file? Those will be to the exercise material session 5 shape file, and this will be river basin UTM nodes, okay? River basin UTM nodes. Okay, with that we extract the vertice. Okay, great. So with that we extract the vertice, and then we have the vertice of our. Something similar on the course material will have also the digital elevation model. As you remember, we are going to get the elevation of the vertex from the raster. Okay, if you are here with me, please type yes 1. If you are here with me, please type yes 1. Okay, so here is our basin, and then what we are going to do next is that we are going to do the point sampling tools from the river basin, okay? And then but we are going to use the UTM, the QuencaDem UTM, that is the raster file. This will be called elevation as well, elevation, and it has to be the same, okay? Elevation with capital E. Okay, it has to be the same because for the next step what we are going to do is that we are going to interpolate among those points. Okay, and then here this will be called, this will be saved as shapefile on the for exercise material session 5 shapefile, and this will be river basin UTM nodes, and this 3D. Okay, and this, with that, what we are going to do is that we are going to extract the elevation and store as the elevation attribute on the output shapefile. Okay, great. So here we have the elevation, and then we are going to add the shapefile that we have created before. Okay, the nodes 3D. Okay, so here we have something very interesting. Okay, I'm going to take anything else than these two last. Okay, this is the one that I got right now, so this is, it has the attribute of elevation, and this is the one that was from the previous part as well, elevation. So we can interpolate among them, we can do it. Okay, and this is what we are going to interpolate. Okay, and then how we are going to interpolate this. But first, in order to interpolate, we have to merge. Okay, we are going to merge those. Okay, so by doing this, we are going to merge those, and then vector geometry, merge vector layer, merge vector layer. This vector general, merge vector layers. Okay, so that's why I only need the two of them, because I am going to merge those both. So I'm going to merge this to this. Okay, the CRS is optional, and this will be stored as this will be wetlands and channel network. Okay, so this will be your merge shapefile. Okay, wetlands and channel network. Okay, if you are here with me, please type yes to. If you are here with me, please type yes to. Okay, there is a great question. Okay, we run this, and there is a great question. Say, why do I want to interpolate the NDVI to the rivers? Okay, great question. Paint is good. Paint. Let's have a review of paint. Okay, let's do a simple drawing of what is going on with a. So here we have, this is a cross section of a basin, yeah? This is a cross section of a basin. Yeah. Okay, great. Okay. Okay, better. Okay. and then I will plot as well the water table. So this is the water table. This is the water table. What happens here is a wetland, and what happens here is a wetland. Why is a wetland? Because this is an area where the water is really close to surface, so vegetation can take water from the water table, from groundwater. So this is vegetated on the dry season. Okay, and what is here, for example, here, this is the river, and this is the river. Okay, so and why is this the river? Because the water is discharging, the recharged water is discharging to the, as you have seen here. Okay, so if we interpolated we have this from the wetlands, the points for the wetland, and then we have here from the river network. Okay, so if we interpolate this, we can have an idea of what is the water table. This is raw, this is kind of very primitive but it has a conceptual point of view. Okay, and if you have no values or of how is the water table, this might help you. So it's better than nothing. Okay, is that right, Manal? Okay, great. So here we have we have already done the merge. So on the merge we have only one table that is called elevation, because it's the same for all of them. Okay, as well we have the basin, where it comes from. Okay, well, okay, so we are going to interpolate this, and how we are going to interpolate? By SP line. So SP line. So on Saga we are going to use multi-level B-line interpolation, multi-level B line interpolation, where we are going to use the wetlands and channel networks. We are going to use the elevation as the point. On method we are going to do with SP-line refinement, and on level 11. Okay, on level 11. Why on level 11? Because SCP line has 14 layers, where number 0, actually SCP line is not exactly interpolation, it's a surface. Okay, so on level 0 is a surface that tends to match the observed values, but without, on the minimum level, and 14 will be on the maximum level. We have done research on that, and we have seen that the more continuous distribution, actually you can read it with number 11. Okay, this is something that we have done it. Okay, and then we are going to save it to 5, and then this will be on session 5 raster, and will be called water table SCP line. Okay, water table WT_SCP line. Okay, if you are here with me, please type yes 3. If you are here with me, please type yes 3 and run your interpolation. Okay, great. So I will run it. Fit, I fit is missing. Where is fit? Fit to the nodes, I guess. Yeah, fit to the nodes. Why not? Okay, so here we have the SAP line, okay, and then here we have our them, and then we can do some very interesting things among them. And which are the interesting things that we can do is that please, I guess that everybody here has the cross section tool, okay. Okay, so we are here, we have the profile tool. The profile tool here could make us some cross sections. Okay, so we are going to do any cross section close to this part. Okay, and then we have to, okay, I will do it again. First we have to do the profile tool, and then we have to add the layers. For example, this will be the surface as a, and this will be the water table with the color of water table. Okay, and then here I'm going to do interpolation, and this is what you get. You get the surface and what it will be the under this approximate methodology, the water table. Here as well you can do any water table that you might like. Okay, and as well here. Okay, if you want that I repeat, I can repeat, otherwise type yes 4. If you want to repeat, I can repeat, otherwise type yes 4. Okay, I can do it again. I can do the profile tool. I can add the layers. I'm going to add the UTM and the SCP line. I can give some values to the layers, and then with that I can do this. Okay, if you have seen, it works pretty well. Okay, sometimes the interpolated water table is above surface, but this is because we are working with approximate methodology, so there is no so much to worry about. Okay, so because this is the limit of what we can see. I hope that this class was helpful for you, and I hope that the next class on Friday is our last class, so we hope that we can see you there. If you have any questions, let me know. Otherwise, we will say as goodbye and type yes 5. That's the end of this class. If you have any questions, let me know. Otherwise, we say as goodbye. And type yes 5. If you have any questions, let me know. Otherwise, we type GIS 5 and say us goodbye. Okay, bye bye. Bye.